Hello and welcome to Bo Beats, and in today's video we are taking a look at the VCV rack. It's a software eurorack synthesizer system that you can use in some very interesting ways. So this video will be about making a basic patch, just how you kind of hook everything up together, and we'll try to make like a basic patch and see where we go from there. So if you haven't checked out my first impressions video where I have some interesting audio examples of patches that I made using this software, you can just check the link in the description if you want to see that first. So let's get into the software, and of course I have my trusted sip of the coffee with me. So what you're looking at here is basically a software eurorack, and if we right click somewhere you see a list of all available eurorack modules. You do have to log in, register first, log in, and then download these modules. They are, I suppose there is a couple of bytes, so it goes really fast. Now, the first thing we need to create a patch is either some kind of MIDI interface or something like a sequencer, the fundamental Sec3, which is a sequencer. So either we use a MIDI interface. Let's take a look at it. So this is a MIDI interface. You can pick your MIDI device. I have the key step, for example, here, and you have your channels here. But we'll not be doing that because mostly when I want to show the software, I try to use the inbuilt sequencer, so it's easier to replicate. We'll just right click and delete it, and we'll use the sequencer instead. So basically you don't need to have a MIDI keyboard connected to make something sound. I suppose there are other ways as well. Next up, I usually add an audio interface. So this device here, you can put it wherever you want, and basically you just choose your audio interface. So I use the Audio Fuse from Arturia, Core Audio Fuse 18 8 out. There we go. And it basically has 8 available inputs. It says here 8 inputs, 8 outputs. This is important because if I use the built-in audio output, it has 0 inputs, 2 outputs. That means that I can only use the first 2. That kind of confused me in the beginning. I thought I could use every one of them, but I couldn't get number 2 and 3 and 4 and so on to have audio when I used a built-in sound card. So I suppose that's some kind of limitation on the hardware side of things. So I usually just put this far back here. And sample rate I usually keep at 44/100 because this software does drain your CPU quite heavily, so I kind of want to keep it. If you increase it, for example, it'll drain more CPU. And block size I usually increase to like 1000. It doesn't really matter. I mean, that will impact latency, but since I'm not actually playing something from a keyboard, well, I don't really mind. And you can get some nasty clicks and pops very quickly on something like my laptop here. So let's add an oscillator. Now there are different oscillators. For example, the Audible Instruments macro oscillator, this one here. You can use this little knob here and turn up and down, and you see there's a lot of different basically I guess wave types. This is I guess this is a kind of a copy of a digital real eurorack module. And we also have, let's see here, here's the fundamental VCO. This is a more standard kind of analog style VCO, where you have your frequency, basically the pitch, and you have pulse width, you have the CV for pulse width, and frequency modulation and some other stuff as well here. So that's all well and good. And I think we have some more strange ones as well. Yeah, the modal synthesizer can also be used to create interesting tones and timbres and so on. So this is very interesting as well. But you know what? We will go with the standard one, a little bit boring one. So we have a VCO. And in order to be pedagogical, I'll put it down here. So basically we have some kind of input here. We have the VCO. That's basically what creates our sound. And next up, the usual setup is VCO, and then you have a VCA. VCA will give I suppose the correct term here is amplitude in English. So it will give volume basically to the sound. And if we just connect them together, let's see here. Let's see if we can do this. Try, and we go from triangle here. These are the outputs. Sine, triangle, saw, and square. We go to the input. And we go to the output of the VCA, and we go to number 1 here. And suddenly we have a tone, but not a very beautiful one. In order to, let's remove the cabling. In order to have control over the tone, we need to add an ADSR. So that basically stands for attack, decay, sustain, and release. Attack determines kind of the snappiness of the sound. Decay, sustain, and release has to do with how drawn out the sound is. So we'll put attack down here, and we'll keep the others around these values here. We can increase a little bit. Now, what we want here is we need some way for the ADSR to know when it's supposed to trigger. So we go to the sequencer here, we put down a little dot here in the sequencer line, telling it to play a note, or trigger a note here. And we go to gate, and basically when you see gate somewhere, and basically that often refers simply to an on and off value. I think that is the technical correct term. So basically you can see it bleeps every time this little dot here is played. That will tell the ADSR to do something. Well, basically it triggers the ADSR, and then we go from the output of the ADSR, because we want to use the ADSR to control something. What do we want to control? Well, we want to control the level of the sound, how much sound and how long and so on. So we go from the output here to the exp here. That is what controls the VCA. But there's still no sound. If we plug from the VCO here, let's say saw, into the VCA and out, we'll get a sound. But as you can see here, when I'm moving this little knob up here, there's no change to pitch. Basically this knob should change the pitch. So why doesn't the pitch change? Well, it's very simple. The gate here only controls the sound on and off in its kind of default pitch. So instead we go to row 1. This up here is row 1, row 2, row 3. Go to row 1. We go to V/octave, voltage per 1 voltage per octave or something like that. It stands for. It's a little technical. That will mean that row 1 and the different pitch here. So we can change the pitch here for number 1. We go to number 3 and we change the pitch as well and put a little dot here. And we change the pitch further here on number 5 here. Now, if we connect, so we've connected the VCO here with saw to the input of the VCA to the and then out from the VCA to the sound card. And now you will get a sound. Ah, so beautiful. But we're far away from the fart noises. And if you're wondering, why is the sound just coming from one side of the speaker? Well, it's a mono sound. And for some reason, I haven't been able to figure this out, it doesn't center. So what I do, and if you know a better way, you can just leave a comment, but this is what I do. In order to get the sound in both headphones, I usually just use a multiplier here. Audible Instruments multiplies. This is very nifty. Basically, you can take something into an input and you get multiple outputs of the same signal. But we're getting ahead of ourselves. I will show you this in a little bit more detail soon. So let's see here. We have basically the sequencer sending pitch and sending gate values to the VCO and to the VCA and ADSR. So we have pitch and we have amplitude. Next up we need a filter. So we go in here and there's of course different filters, but we'll go for the fundamental VCF. This is just a normal filter. It can be a low pass filter or a high pass filter depending on what output you choose. Let's go for a boring standard low-pass filter. So we'll go from the VCA here to the input of the VCF. So the signal chain is pitch from row 1 into the VCO, and then we choose what waveform we want, or what kind of sound we want, into the VCA, into the VCF. The ADSR doesn't really have anything to do with the sound itself, or what I call the sound, the pitch. It of course impacts the sound, but it doesn't have anything to do with the pitch. It has to do with the gate. So the VCF here controls the frequency, and frequency as in at what point will we cut it off. So we go from the LPF here to the output, and suddenly we can control it, but it's still just in one on the left side here. So we'll instead go from the LPF, from the low pass filter, to the input here, and now we have multiple outputs. So we go output 1 here, output 2, and for some reason this makes it's not stereo, but it's centered. I'm not sure. Somebody can probably put a comment down below and tell me what I'm doing wrong here, why it's not. I hate it when outputs are, well, maybe it could be, just to think I maybe found it out. Maybe it could be that the sound card itself always routes audio in channel 1, for example, to the left. And yeah, that could be it. I could probably experiment with that. Never mind. Let's get back to business. So we have this beautiful little sequence running here. So basically we have a sound. And if we want to stop it, we stop the run up here. Now, sometimes you can hear here, like this, notes are hanging. And if you press reset, nothing happens. Basically, I just click run very quickly. I suppose it's a hanging note of some kind. Now, if you want to exchange the sequencer 3 here for a MIDI interface, you can just go to MIDI interface. And basically, if we look here, MIDI interface has 1 volt, octave, and gate. And if I just change it up here, so we put gate, and we go from row 1 to 1 octave, and MIDI channel, let's use the key step input, and input 1, and I should be able to hear something. And before we can get into some truly fart noise 56K modem type sounds, we need a little sip of the coffee. So what can we do now? Well, we can add some modulation with an LFO, for example. So here's a titled modulator, and I suppose this is just pretty much a LFO. And down here we have the outputs. I can't really explain the technical differences between these outputs. I haven't really figured it out, but basically we can go from the high here, and we go to frequency. We want to modulate the frequency of the VCF here. Then you have to use the frequency CV here to kind of set how much or little. So we can set it to about 10 past, or let's set it to 10 past, and we'll start it, the sequencer. And suddenly if we remove it, you can hear the difference. Now we can decrease it up here, the frequency knob, and we can change up the shape. And we can smooth it out. And since this module here, this frequency, stop it. And since this LFO here has multiple different types of outputs here, we can use several of them to change up the sound. So basically we added modulation to the resonance. We can go into audio rates. Kind of interesting. Now let's add a delay to this as well. So we'll go from at a fundamental here, delay, and we'll go from the LPF here into the delay and out from the delay into the multiplier. And let's see if we can use this LFO here to modulate. You can see here CV, 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 the parameters here for time, feedback, and so on. Let's see if we can just make something really crazy. So let's start the sequence here. Basically now we're modulating the time of the delay, which create pitch changes. And let's use it on the feedback as well. Now, if we truly want to go into some interesting territory, we can use one of the more interesting interesting eurorack modules here. So let's use something like the, let's see here, like the texture. Now, I'm not entirely sure what this does, but it does some really interesting stuff. So let's pause it here. You can see that there's some hanging notes, of course, because stuff is still modulating. So, but let's just introduce the texture synthesizer here. And basically what I usually do here is I just go from say the output of the delay into this one here. It's supposed to be stereo, I think. And I just go out from it. And we can just start messing about. And using the pitch here is really interesting. We can even try, let's see if we can modulate the pitch. So we can add a multiplier here. Add a multiplier. Instead of going from the buy to the CV down here on delay, we just go via the multiplier. And use the same source for modulation here and modulate, let's see here. Let's see, what did I think? Modulate the pitch. Where's pitch here? So as you can see here, we go into the V-oct. I think that corresponds to the pitch. I'm not entirely certain, but you can hear that there's some interesting differences here to the sound. And we can go from the same here, using the same here to for example, size or texture. So we've made a one-voice synthesizer using the VCV rack and added some modulations and some crazy stuff to it. I hope you enjoyed this little tutorial here. If you want to see more videos like it, be sure to press the like button, leave a comment, tell me if you want to see more. And if you want to support me further, you can always check out patreon.com/bowbeats. It's a place where you can support the work I do here on YouTube, and there are some interesting rewards. So thank you so much for watching this video, and I hope to see you in the next one. Thank you.